Have you ever wondered why some data points are more frequent than others? Why, for instance, the height of a typical human seems to hover around a certain number, or why most students score within a particular range on a test? There's a fascinating mathematical concept behind these occurrences, and it's called the normal distribution, or the Gaussian distribution. Picture this, an elegant, bell-shaped curve, symmetrical and balanced, representing a world of data. This curve embodies the normal distribution, showing us that data near the mean, or average, happens more frequently than data far from it. Imagine you're in a room full of people. If you start measuring everyone's height, you'll likely find that most people's height is around the average, with fewer very tall or very short individuals. This is a real-life instance of the normal distribution in action. Or consider test scores. Most students will score around the average mark, with fewer achieving extremely high or low grades. Again, this is the normal distribution at work. The normal distribution isn't just an abstract mathematical concept. It's a phenomenon that permeates natural science, social sciences, business, and economics. It helps us model and understand everything from the weights of objects to stock prices and manufacturing defects. The normal distribution is defined by two parameters: the mean, which is the average, and the standard deviation, which tells us how spread out the data is. These two elements shape the bell curve and give us valuable information about our data. There are a few critical properties of the normal distribution to remember. First, it's symmetric about the mean. That means the chance of a value being less than the mean is the same as it being greater. Second, the mean, median, and mode of the distribution are all equal. And lastly, a certain percentage of values fall within 1, 2, or 3 standard deviations of the mean, approximately 68, 95, and 99.7% respectively. The normal distribution also lets us calculate the probability of a particular value occurring. Suppose we know that people's heights are normally distributed with a mean of 175 centimeters and a standard deviation of 10 centimeters. We can calculate the probability of a person being taller than 185 centimeters. We convert this height to a z-score, which tells us how many standard deviations it is from the mean. Then, we can look up the probability of this z-score in a standard normal distribution table. So, in essence, the normal distribution is a powerful, versatile tool for understanding and modeling data. It permeates fields from science to business and is a cornerstone of many statistical methods. And the next time you're in a room full of people, you'll know why most of them are around the same height.